Let's now apply the equations for the discharge and the continuity equations to solve the following problems. So for number 1, compute the discharge of water through 75 millimeters pipe if the mean velocity is 2.5 meters per second. So the given are, the diameter of the pipe, then the mean velocity. So what we're asked here is the discharge. So we assume that we solve for the discharge or the volume flow rate. But you can actually solve for the weight flow rate and mass flow rate here. So for the solution, we'll just apply the formula for the discharge for the volume flow rate, which is equals to area times velocity. And we substitute all the given values. So for the area, we apply the area of a circle, which is pi over 4 multiplied by the diameter squared. So we have 0.075 squared times the velocity, which is 2.5 meters per second. So the answer would be the discharge is equal to 0.011 cubic meter per second. Then we can actually convert it into liters. So in terms of liters per second, it is 11 liters per second. So next item here is the discharge of the air through a 600 millimeters pipe is 4 cubic meter per second. So compute the mean velocity in meters per second. So the given are, the diameter of the pipe and the discharge or the volume flow rate, which is 4 cubic meters per second. So again, we are required to solve for the mean velocity, and again, we will just apply the formula for the discharge, which is equals to area times the velocity. Then we have a given discharge and the area, so let's just substitute it onto this equation. So we have 4 cubic meter per second equals to the area pi over 4 times 0.6 square meter times the mean velocity. So the mean velocity is equals to 14.15 meter per second. So for the last item here, we have a pipeline consists of successive lengths of 380 millimeters, 300 millimeters, and 250 millimeters pipe with a continuous flow through the line of 250 liters per second of water. So compute the mean velocity in each size of the pipe. So we have the given diameters at each section of the pipe. Then since we'll just apply the law of conservation of mass under continuous flow. So the volume flow rate or the discharge at every section is just the same all throughout. Then we have to solve for the mean velocity in each size of the pipe. So again, from the continuous flow, the discharge at all sections of the pipeline are the same. So that's why we have Q is equal to Q sub 1 plus Q sub of 2 equals to Q sub 3. Then, to determine the velocity at the, let's say, section 1, we have, the discharge is 0.25 cubic meter per second. Then for the area, we'll just use the diameter 0.38. So the mean velocity at section 1 is 2.2 meter per second. Then for the the mean velocity at 300 millimeters pipeline. So we have 0.25 cubic meter per second equals to pi over 4 times 0.3 squared. So the mean velocity is equal to 3.54 meter per seconds. Then for the mean velocity at the third section, so same procedure will be applied. So the mean velocity at the third section is 5.09 meter per seconds. So as you can notice, as the diameter decreases, or as it as the diameter gets smaller, the velocity increases as long as the volume is constant all throughout the sections.